In this video, we're going to construct geometric proofs using bisectors. Now, bisectors can mean one of two things. The very first thing a bisector means is an angle bisector. So if you were told that DG bisects angle EDF, the first thing you want to do is you want to find angle EDF. So angle EDF is this guy up here, right? So now that we know that this is the angle that's being bisected, we have to think about what bisect means. Bisect means to cut in half, which means this angle that we just found is being divided by this DG into two congruent halves. Now, the way to mark that is kind of just how you see. I'm just going to change it up a little bit. I'm going to pretty much make the same mark again, I'm not going to lie, but I'm just going to show you that it means that this angle here, let's make it a little bit thicker, this angle here is congruent to this angle here, okay? And that's important because I may eventually want to prove that those two triangles are congruent. But this is a little mini proof just to show you what an angle bisector does, okay? So if I see that DG bisects angle EDF, that's my given, I now know that those two angles are congruent. So that means my very next statement is going to be angle, and we have to name this first angle. So again, D is in the middle, that has to be my middle letter, but I'm going to start at E, go to D, and then down to G. So that means angle EDG is going to be congruent to angle, and this way, FDG. Okay, and the reason for that is an angle bisector divides an angle into two congruent halves. And that's a definition we've seen before. So this is just defining an angle bisector and showing that it gives us those two congruent angles. Now, again, this is just one type of bisector, an angle bisector. The second type of bisector is a segment bisector. So a segment bisector, this time instead of cutting an angle in half, is going to cut a segment in half. So you'll see some of the same language here, right? AS bisects, but here, instead of, you'll notice over here, I'm going to go back. Over here, there was an angle that was being cut in half. Here, it's a segment. So it won't say segment bisector, but the piece that comes after the word bisects is what's being cut up into two congruent pieces. So in this case, it's RT that's being cut up. So let me make this a little bit thicker. RT is this piece here, and AS is doing the cutting, right? So AS is dividing it into these two congruent pieces, one here and one here. Okay, so this is giving me two congruent sides, which is very helpful. So again, AS is bisecting RT, which means RT is what's being cut in half. So when RT is cut in half, what do we have? Well, we have these two pieces. The first one is RA, so now we know that RA is congruent to that second one, which is TA. Okay, so RA is congruent to TA because a segment bisector divides a segment into two congruent halves. So it is quite literally the same reason. The only difference is in a segment bisector, we say segment bisector divides, and in an angle bisector, we said angle bisector divides. So it really is the same thing, just two different times. Okay, so now we've gone over how to use these in proofs. Let's go ahead and solve a proof or two. So this is a proof. It's a little bit of a spoiler at the top because I'm telling you it's going to be an angle bisector proof, but let's pretend like that spoiler alert's not there. We're going to color code our givens like we typically would. So it's saying that DGE is congruent to angle DGF. So DGE is this angle here. Careful, I know it looks like a right angle, but nobody's telling me that it is, so I'm not marking it as if it is. And DGF is right here. So I have those angles. Now, this second given, I see the word bisect. That's really important, right? Let me actually go ahead and underline it. The word bisect, and what comes after it is an angle. So that angle is getting cut in half. So this angle, again, I'm just going to highlight it because we're still learning. EDF is the angle that's getting cut. This is getting cut into two congruent pieces, right? So what that really means is that this angle here is congruent to this angle here. And we're putting the two markings because we don't want to get it confused with our first given. All right, now before we go into writing the proof, we really need a method. And I always talk about the fact that they don't ask you for a method, but you really need it to start. So if I look at this, and I always kind of do the same thing, but I'm going to go ahead and let's see if I could do it here. So in class, what I do is I always draw, let's see, it might not be as easy on here, but of course not. Let's do it this way. I will take my hand and I will cover one of the triangles. So let's say I'll cover this triangle, right? Do I have enough markings there in this triangle that you could still see to give a method? And I don't. I only have two. I have my blue angle and my green angle, right? So that's not enough, which means those two givens do not give me enough to signify a method, which means the diagram must give me something. And hopefully at this point you're seeing that the diagram gives you the reflexive property. So that means that I can prove these two triangles congruent using angle, side, angle. Okay? Now we're going to go ahead and we're going to write our proof. So we're going to go step by step with the givens. So that means statement number 1 is going to be angle DGE is congruent to angle DGF, and that is given. And I call that a one and done given because that right away gives me an angle. One and done. Okay? Now I'm going to write my second given. My second given is that DG bisects angle EDF. And that's given. This is not a one and done given because this here is not telling me that an angle is congruent to an angle or a side is congruent to a side. So I can't cross off or check off a side or an angle. So I need another statement after this. And we need to think about what a bisector truly does. It cuts it in half, right? So what we're going to do is we're going to think about what's being cut in half, that angle EDF. If you're unsure, if you're not quite sure what to do next, you can always, as we're practicing, as we're learning, of course, use your interactive notebook, the front page, the one we just went over, or you can turn into your special steps and proofs. So if I take a look at my special steps and proofs, angle bisector is actually right here on that front page, right? So when you're given an angle bisector, like you are here, right? We see bisects and we see it's bisecting an angle. The next step is to write the two angles that it's broken into, right? And you'll see here, it shows us those two angles. So we're just going to, and then it gives us our reason. An angle bisector divides an angle into two congruent halves. So the whole point of special steps and proofs is it's giving you the template that you need. You just have to change the letters, right? So in our case, when we go back here, the two angles that were given are this EDG, so angle EDG is congruent to angle FDG, right? So it's the same thing as our special steps and proofs. We're just changing the letters. And the reason is, same thing that we see over there, an angle bisector divides an angle into two congruent halves. And I want you guys to pay attention to this because here, now I have an angle congruent to another angle, which means I can go ahead and check this off on my method, right? So this little grouping, this little two-statement blue piece is what we get when we are using a bisector. So now you will notice we have two angles taken care of, but we still need our side. And our side was that reflexive property, right? So we're going to go ahead and we're going to do step 4. And step 4 is going to be that DG, also on your special steps and proofs on the first page if you need it. DG is congruent to DG. And the reason for that is the reflexive property. Okay, and that is my middle side. So now that I have everything I need for my method complete, I can go ahead and I can write my proof statement because I have everything I need to prove this. So my final statement, I'm going to write step 5, and that is going to be triangle DGE is congruent to triangle DGF, and the reason is angle side angle is congruent to angle side angle. End of proof. Okay, nice little 5-step proof. So we had one given that was a one and done. Then we had our, so I'm just going to mark it up here. We had one given, which was a one and done, right? Then this one was a little +1 kind of deal. And then we needed the reflexive in there as well. Okay, so use this box up here to make a list of all the things you need to help you. It's meant to be a planning place. Okay, so now that we've done an angle bisector proof, let's go ahead and do a segment bisector proof. And again, these are titled because it's your interactive notebook, but we won't always know. So let's go ahead and let's mark what we're given. First, we're given that angle R is congruent to angle T. Then here's our bisector, right? So it says bisects, AS bisects R. I know I keep doing that one. I really just want to underline it. Bisects RT. So what's being cut in half? RT, which means this piece here is congruent to this piece here. That A in the middle is cutting it in half, right? And then this one's a nice one and done given too. It says RS is congruent to TS. Again, I'm using 2 hash marks there because I don't want it to get confused with my other blue markings. And the method here, which is always very important to denote, is going to be, you guessed it, side, angle, side. So that'll help us to mark things off. Okay, so we're going to go ahead and start with our very first given. So step 1 is going to be that angle R is congruent to angle T, and that is given. And that is a beautiful one and done given. It gives me my angles. Done. Next, step 2. AS bisects RT. That is also given. That is not a one and done given. That is not telling me that an angle is congruent to an angle or a side is congruent to a side. So I need more information. AS is bisecting RT. Again, if you are unsure, go to your special steps and proofs. Take a look down here where it's talking about a segment bisector, and it'll go through all the language again. You need to show the 2 sides that are congruent, and you need to talk about a segment bisector dividing it into 2 congruent halves. So we're just replacing letters here, right? So if AS bisects RT, that means my very next step is that RA is congruent to TA. And why is that? A segment bisector divides a segment into 2 congruent halves. Right? Okay, so now that part's done. And that gave me a side. So all I have left is my very last side. And this is really exciting because this is going to be a one and done given. So step 4, RS is congruent to TS. That is given. We love it when that happens because that just gives me my last side, which means my method is done and I am ready for my final proof statement. So we are going to write our proof, which is that triangle RAS is congruent to triangle TAS, and the reason is side angle side is congruent to side angle side. So these are just proofs using bisector routines. It's just this little section in here. Every time you have a bisector, it follows up with that next little statement and reason. and you can use these all the time, and they're quite popular in proofs, so you will be using them very frequently. Remember, it is cheating if you use your cheat sheet on a test, but if you are not using it before the test, you are not being resourceful. So keep in mind that this special steps and proof page is there to help you. It has all of our favorite things, right? It has vertical angles, it has the reflexive property, it has our perpendicular line routine, our angle bisectors, it has altitude, and everything that we've learned up until this point. So go ahead, study your special steps and proofs, come back to this video if you need any help, and let me know if you have any questions.